Okay, so I'm going to start recording. Okay, perfect. Okay, so I'm just going to assume that you don't know anything. So
Okay.
that's where I'm going to just kind of start. So
Okay.
don't be offended if it's too easy or too slow, or if you know stuff already. I'm just going to start at the very basic as if this is your first time seeing sill detail, sort of.
Okay.
Sort of. Okay, so I'm just going to start and just jump right in. So,
Mhm.
all right, so you have the captured on the left, the inviso on the right. Obviously, the glass is the biggest difference, as well as the face, right? What metal we're going to see versus not see.
Mhm.
You have the sill member, and so this is where the terminologies come in place.
Mhm.
So this body up here, so I changed the color of the sill track itself to yellow. So the sill body, I mean, some people just call that the sill, sill member. Some people still even call it the horizontal, but you have the two different components that make up a sill. So
Mhm.
there is some type of body, which is what the glass goes in, whether it's captured or inviso. And then the main part of the sill is this track. So this also has various names and terminologies. People call this the sill runner, sill track. Some people call it a can even. Um, Starter track, starter sill. That's all relating and talking to the same part. So the reason they call it a starter track or starter sill or that kind of terminology is because this has to go in first.
Mhm.
So this yellow part is a field use item, and the field has to lay this guy out first, and it's not done in the shop. So everything related to this sill track or starter is all done in the field. Okay, so that's kind of just a big uh, kind of separator between these two. Okay, so you have this sill runner or track that has to be placed first. And if you imagine you have just, if you go out into the field, they just have a bunch of concrete or some kind of floor slab. They have to lay this thing out. So I don't know actually what dimension point they use to lay out these sill tracks because we don't dimension anything for them. So it would be a good question to ask the field, how do they lay this out? Because our dimension point is to face the system. But if you imagine to this piece, there is no faces system. And this part isn't there yet. So the field really has, nothing to work with. So I don't really know how they lay this out. So, but in order to lay this out though, they need to know how it's anchored. Okay, so that's what this bolt is showing in this case. So this anchor is strictly for the sill track. The bolt is not related at all to the mullion. It's not related to the verticals. The only way it's related to the verticals is the spacing. Okay, so this sill track can run maybe spans of 20 feet, whereas our units are maybe only 5 feet. So you can have one sill track that spans under multiple units, and that's normal. So the way they lay out these holes or the anchors for those sill tracks, they use the mullion as a guide for spacing. So this one sill track could have 12 holes in it, depending on how far away the mullions are from each other and how many units there are. So this really, even though it kind of looks like it's related to the verticals, it's really not. But our call outs usually say 2 per vert, 2 per jam, because that just gives them the spacing. And that's how the engineer calculates it. So these bolts are placed near the mullions, but not directly at the mullions. If that makes sense.
Yeah.
Okay. All right. So then you have it anchored in place. And then you have this index clip, which is this hidden line.
Mhm.
Okay, so this hidden line is an index clip. So it's exactly what it's called. Doing what it's doing is called an index. So it's indexing the units. So it does go in at every vertical mullion. So that is actually inside the vertical. So that's why we show it as a hidden line. So if I look at our vertical mullion, I'm just going to pan down here really quick. That index clip literally goes inside the mullion here, somewhere inside this cavity. And I actually think they actually put it in the bayonet raceway here. Okay, so if this were, we were looking at the top of that index clip, it would be right here at every mullion. So the reason why we need it is because you could see how we have this 1/4 inch gap between the verticals. So if we didn't have the index clip, this 1/4 inch could get smaller or bigger. These mullions could move. So it could be like this by accident. You know, so it could accidentally be spaced wrong. So the index clip helps the field lay out the units next to each other, and so that they truly maintain the 2 3/4 overall dimension from the male to the female. And so that's the purpose of the index clip.
Okay.
Okay, so the index clip has to fit inside the mullion. So if you have a wider mullion, you're going to need a wider index clip. So that's why we took off the notes here that said the size. So we used to call out the size, but it was only true at a 2 3/4 vertical. But we've had jobs where sometimes they have a 4 inch vertical or a 3 inch vertical, and then you would end up having to call out all the different sizes here, which nobody was doing. So that's why we now wanted to build the logic in the installation manual that tells the field, the shop, that they have to take the width of each vertical and then size it down a certain number to get the size required per vert. So that's why we took out that dimension here. Also, the height matters because, as you can see, this line down here represents the bottom of the vertical. So it has to fit inside it. So as we've seen, when these mullions get taller, or these stack joints get taller, the bottom of mullion gets higher, then the index clip no longer works. So it has to have proper engagement to do its job. So that's just something we have to look out for when we get taller sill tracks and taller sills, to make sure this index clip is fully engaged properly. And that's why some jobs we had to go with a taller index clip. Okay, and this index clip is only shown in the sill. Okay, so I have the little ISO from our manual here to show what we just so far talked about. So you have the bolts that go in sill track to sill track. So this is 2 different sill tracks. It's what we call our splice location, where 2 pieces come together. I haven't yet talked about the splice sleeve yet. And then here's the index clip, just a little visual, that it gets pre-attached to the sill track before they put in the units. And again, that's all done by the field. So they have to lay out all the mullion layouts to know where all these index clips need to go before they can put in the units. And it's just attached with 2 fasteners, 2 little screws. So the other question I have comes up sometimes is the, and we've seen it in a lot of details where the engineer wants to beef this up, or we've seen some where they put 2. So it's just because they're worried, or they feel like this clip is taking a lot of movement and that maybe the units will shift. But again, that's where the logic doesn't really hold true, because it's really just an index. It's not structurally doing anything. So that's why it's a little odd when the engineers do that. But that's something Jumpstart needs to figure out and talk with our engineers, because really this clip is not taking any load. It's just truly an index to space our units. Okay. All right, so then we'll lead to splice sleeves. So again, as I mentioned, this sill track can span, 20, 25 feet across an opening, and then it has to stop, and then another one has to start. So again, we have a splice between 2 parts. Usually that splice gap that we leave between the 2 parts is a 1/4 inch. And so This red dot here, the 08T, that's our splice sleeve and how it's shown in this detail. And then here, I just wanted to show you the ISO of it. So that red line represents this little black sleeve. That's basically, it's called Dow 123. It's a silicone rubber sheet, basically. If you imagine a big white rubber band that's flat, that's what this material really is. We model it in our details like this as black, but really it's clear or white. And then if you see it out in the field, actually, they just smother it with sealant. So the reason they have to smother it with sealant is because water can get between any little crack. And now that you have two pieces together with a big gap, you want to make sure all of those gaps are covered so that water won't go through those cracks. So they will cover this whole thing with sealant. Even though our drawings show it all nice and pretty, they really just smother it with sealant. And then they have to smother going up and over what we call the chicken head of the sill track, so that the seal, if by chance water pulls up in this cavity, it won't go up and over, because behind the sill track has to stay dry. That's what we call our dry area. We are allowing water to be in the front cavity, and we expect it to weep out. So if we go back to the detail here, we are expecting water and allowing water to come in this front area in front of this gasket 48. And then if any water comes here, we're expecting it to drip out. And that's what these little drips usually we show in our details. It just shows if by chance any water gets in there, this is where we expect it to come out. And we're okay with water being in there. So that's why that sealant at this splice sleeve is super critical because we don't want to let any water come up and over, because once it gets behind this chicken head, now that's basically a leak. And that's where we can't have water back here.
Why don't we call the sealant out? Like, or is it just known?
It's just known. So that's why it's kind of in our installation manual.
Okay.
Bed and seal. So that's one of the field kind of their installation stuff they have to remember to do. And that's why in our installation manual, we show it and we say, bed and sealant, and they just know that's part of their, I'm sure part of their training. All silicone sleeves, fully bed and sealant. But yeah, we don't show it. So exactly though. So that's why I said there's stuff that's happening that we don't always show. And that's just for clarity, because otherwise this would just look like a big smother of sealant, a hatch, and you won't really see the detail anymore.
Okay.
But yeah, good question. Okay, so that's the sill track and the splice. Okay, so then just to go over these gaskets a little bit. Gasket 48 is what we would call a dual compound gasket, which means this back part. So if you could see why the lines are drawn like this. So this part is one segment and this is another. So that's on purpose. This back part is like a hard plastic so that it doesn't move. So it literally gets slid in. It doesn't get wedged in, it gets slid in across. And again, imagine 20 feet long. So if I show you over here. So that's what this is here. Sorry, bad picture. But the shop has to slide that in the raceway. And they just slide it in the extrusion the whole length. Okay, because that's a plastic piece so that it stays put. Because this is the critical water gasket. And then this front part is actually squishy. So the front part is like a soft gasket durometer where it can squish, but the back is a hard plastic. And so that's on purpose. And so the squishy part is just so when they install, it'll smush between, you can see how it touches the sill member here. So that way they have, it can squish and it won't be rough, but they don't want this dart ever moving. So that's why they make this a hard plastic. So that stays put. Okay. Then you have this guy, this 47A. So this is actually an aluminum rod. I don't know if you've seen one before. Yeah. Okay. So yeah, it's like a straw, but it's about this long, 4 inches or so. And it's a aluminum piece. And we say 1 per vert. And there's been a little controversy on that, if they actually put it at the verticals or not. I'm not sure. Because sometimes they say, I've heard Kendall say, it doesn't have to be at the mullion. It could be just anywhere, because it's just to help ease of installation of the sill track so that it can kind of roll in its place when they're installing it. It'll kind of spin on itself so that it'll just roll into place. And so he said the more it's done at a vertical, it's maybe more friction. So Kendall, I've heard him say it doesn't have to be at the vert. So I don't know exactly where they put it. We call it out 1 per vert just for quantities. So that's like a little something. I don't know exactly where the field or shop puts these, their actual spacing. But that's the purpose of it. It's for install, and then it can round, it's round so that it can roll, the unit can roll over it and not get stuck. Okay, so far so good. Okay. And then the new little guy is this little thing here. So this is, again, it's a new design. It was copied from our Seattle office. And really all it is for looks. Because if you imagine our little detail over here, on the inside, if we don't have that piece, this is just a big gap. And so they're saying that doesn't look good out in the field. So we came up with that design to just cover over this little splice with metal. So that's all that it's doing. So it's almost like a splice sleeve, but it's exposed, meaning you can see it, and it's made out of metal, not rubber. And it's only at these splice locations. And so these splice locations, again, remember it happens maybe at 20 feet. So it doesn't happen at the vertical. So that's where a lot of people get confused. Because again, our 2D detail, everything just overlaps, but you don't see the space. So it looks like it's hitting the verticals, but this is not happening at the verticals. So it has no relation at all to the verticals. It's really just for the splice sleeve, and it's the splice locations of the sill track, which could happen mid-span of a unit, nowhere near a mullion. So again, that's where the 2D details are squished. So you have to kind of see it in space and know where these things all are happening in relation to the sill track itself. Okay, any questions so far? Okay. Okay, good. And then you got this gasket here, 304. So this is way in the back. And again, it's touching the sill track. So again, that's another critical seal. That's an air seal. So basically, it's not for water. It's just air is going to get in here, you know, from just natural airs blowing. And so this is helping prevent the air from just being sucked into the building, and you hear whistling sounds, or and to prevent water, because usually air will suck water in with it, right? If it's strong enough. So this is just our final little defense, line of defense for air and water. And so that's a critical gasket for the system to work properly. Okay, so that's the sill track. And as you can see, from capture to Inviso, it's exactly the same. So sill track, sill runner, the logic is always the same. Like I said, the only variables is if the track gets higher, taller, because the different loads we're taking. Okay, so captured and Inviso, everything's the same. Yep. Okay. So then this leads to the vertical, how it interacts with the vertical, and then these notches here. So you're familiar with these lines, which represent the notch in the vertical. So, excuse me, again, remember this sill track is going to run 20 feet or so, and then units are just going to go over it. Okay, so in order for the units to go over it, they have to be up and over to capture and go over these parts, otherwise they'll collide. So these lines represent what's happening at the vertical itself. And as you know, there's the difference between a wind load, which is when the notch has allowed space between the chicken head and the mullion. So this mullion is literally hanging, floating from above, and it's allowed to move up and down. So that's what the wind load is. And we have all these notches in here because if I move this down 3/4, oh, see, even that notch is the wrong size, see? But it's supposed to clear these parts. So in a worst case, if the mullion does move down 3/4, which is the maximum, it should not hit anything. So something's wrong here with this notch. It's probably the wrong size. You can see that. But that's how those size of notches are created. And that's the purpose of them. So then if I move this back up 3/4 to where it's supposed to be, this is how the system is designed for the mullion to be able to move up and down. And 3/4 is the max for this particular one. Okay, so just keeping that in mind, just to talk about movement real quick. So remember, this sill member, the body, is attached to that vertical, right? So if the vertical moves down, this would move down with it. So let's just see what happens, right? So I'm going to move this all down 3/4. Okay, so that's the worst case. So this gasket would get smushed, compressed fully, but you can see why we designed the face cover the way we did. Okay, see, so that it clears it in case it goes down that much. So that explains a little bit of the design and why we do that. And then you can see how critical it is that the sill body itself, the bottom of it, is equal to each other, you see? Right, so these back legs have to align with the bottom of that. Otherwise, if it moves to its worst case, it won't work. So those are just also little tidbits to see how the system is designed, how it should be designed. So if you see something where maybe this leg is lower than this body, we have a problem, right? Or if we see a captured face that doesn't have this offset, we'll have a problem. So it's just kind of give you little insight into the design so you can see why or if we have a problem, potential problem. But that's why it's designed this way. Okay, so then you have the dead load notch, which again is the notch in the vertical. And that's where it's notched specifically to sit or rest on this chicken head. And that's where all the weight is going in this case. So now it's no longer floating and it's not expected to move at all. And it's just sitting and resting on this part. So that's just the only difference between wind load and dead load, the notches. Okay, so I wanted to show you, one more thing before we get to that. End dams. Okay, so we talked about this sill track running all the way through 20 feet or so, and it just goes unit to unit to unit, goes all the way across the whole opening, but then it has a starting point and it has an end point. And so starting point usually is at a jam, right? And so we have the end dam. So this is kind of an ISO snip of the end dam and what it looks like in real life, and how it's related to the sill track itself. So if you look in our details, again, we took it out. We used to show them in the side view, but it was just too cluttered and usually it was wrong. Okay, so you will not see an end dam in our sill track details. You'll only see the end dam in the jam details. Okay, so this is your end dam here. Okay, so all of these lines, the hidden lines, represent the legs of the end dam. And so I'm sorry, I can't see the back one here, but imagine this end dam has another leg sitting in this back cavity, just like it's detailed here. Okay, and then you can see that it's offset by 1/4 of an inch from the edge of the mullion. So again, that's like another splice or a purposeful gap for sealant. So you can see we show all of this sealant here. So that gives the field a nice spot to put sealant and have space, because the more sealant they can put, the less chance water is going to get through. Okay, so this whole thing is bed and sealant. So again, kind of we're a little generous in our detail, but again, this is not even how the field would do it. They would smother it, again, completely smother it with sealant. Again, because you don't want any chance that water can find a little crack and get through, because this is, again, when two pieces of metal come together, there's a chance that water can get through. So they have to smother it with sealant so that water can't get through. Okay, so they smother it with sealant. And then again, there's a reason why the front fastener is sealed and not the back. Do you remember why? So why we have sealant on this one, but not this one?
Because that first one is where the water would be.
Yes.
It's like the water zone, and then the back one should be the dry area.
Exactly, correct. So there's a reason for that too, right? Sometimes some people think, oh, just seal them both. It's like, no, this is intentional because there shouldn't be any water back here. Exactly, right. So that is on purpose. So it's not a mistake. And that's what's holding this end dam in place, and it's attached to the sill track itself. Okay, so again, it has no relation to the mullion itself. It's not touching the vertical at all. It's strictly attached to the sill track. Then the only other little caveat to look out for when we're talking about standards and end dams is this leg here, the vertical leg that's sticking up. So you can see in this detail, it's sticking out this much. And that's on purpose because that's where the sealant is going to be for this captured vertical. But when you have an Inviso, we chop that leg off. So that's the only visual difference of the end dams, if it's a captured versus Inviso jam. So that's just so that it doesn't stick out when the field is doing this perimeter seal. Because if you imagine on an Inviso, this sealant would be back here, and then this leg would stick out, and we don't want that. But otherwise, the logic of an end dam and everything's the same. Our standard is 3/16, and we recently changed it from Aladyne to painted is our current standard. And it's painted black, I believe. Okay, so that's the end dam at the end. We went over the splices in the middle, index clips at the mullions, and the notches on the verticals. Okay, so now we're going to get into a little bit of detailing, also logic, so that you can check it as well as understand now how does this relate to the vertical members that it encounters. Okay, so and then also I'll just show you a little bit like drafting maybe tips, I guess you can say. So as I mentioned, right, you have a 2D detail. And right now, if we just look at the sill track, there are no dimensions. We don't show any dimensions to it. So how do you know how it relates to the vertical mullion in our vertical details? So the way I do this is I look for a point that's consistent. So in this case, it's the back of system. So if I just draw my construction line from the back of 7.5 system, draw that down. You can see the back of the mullion aligns with the sill track. So I use that as my guide. So there's the sill track. Okay, so I use that as my guide. So what I do to get this in relation to the verticals is I would do a Control-C. I'm going to copy this sill track and I'm going to use the back corner of the sill track because I know that should equal back of system. And then I go down to my vertical detail. And then I do a Control-V and I paste it. Here, let me just show you. I'll just do Control-C. I'm going to take the corner of the die. Click on it. Okay, then I'm going to come down to my vertical detail, Control-V, and I'm going to use the back of the mullion as my reference point. So just, okay, but now it's in the wrong orientation. So then I'm just going to rotate it using the back corner again, just 90 degrees. Okay, so now I have kind of like an orthographic side view. So I'm going to just move it, make sure my ortho is on. But now I have an orthographic side view, and that's how I got these lines in the right spot. And those lines, as you can see, represent the, like, again, if we were looking down on this sill track, we would see these edges. So this is where the back leg is, or this upturned leg. I don't know what we call this upturned leg. And then these lines represents the chicken head. So you can see where it falls in relation to the vertical. And then the front of the sill track itself. So that's where all these yellow lines are. So that's all I did. So that's how you can make sure you get it in the right location. Okay. So I have it already over here. And so all I did was copy and trace all those lines all the way across my vertical detail. So you can see how that sill track relates to now the vertical mullion looking down on it. Okay. So one little thing I noticed by doing this.
I was just going to ask, like, is there a, in this jam view here, because I know when I'm drawing my lines for that sill track, is there a standard stopping point, like offset from the, like that inside of the main body there?
Yeah, so that's a good question. That's a fab logic question, but you can see, I was just about to go over that. These lines are supposed to represent that sill track, but you can see they're off, right? Because this was our old W75 lines. See, and nobody's fixed that. But see, by only doing this exercise, did I notice that? So that's technically wrong. The standard details should be updated. But the other caveat here, just like what you said, is I don't think we run that edge of sill track that far anymore.
Like, so, you don't think it comes like, so like in this, like, so just for example, I have a detail up on my my other screen here, and it's showing the sill track. It's showing it like almost all the way, but maybe like a, not even a 16th away from the back of that main body.
The back this way?
Like, here, I'm just gonna mark, sorry. Like, it's actually shown like stopping like a little closer than that, sorry.
To the inside edge of the,
yeah, inside edge, there we go.
Right, yeah, exactly. Yeah, and that's the thing. I think it does stop there. So that's where, see, again, we have an error. See, and so this is why it's good.
That really shouldn't even be existing on this.
This shouldn't even be there. Yes.
Okay.
Exactly right. No, you're exactly right. See, that's why it's good to understand it, because see, now you can understand what those lines mean, and now you're able to catch a mistake. So that's the power I want to give you. Like, you should know what those lines are, and then you should know, hey, that's not right. So that's exactly what yes. So you're absolutely right. And like you said, I believe, yes, it is. I'm just going to exaggerate, but I'm going to draw the line on the inside edge here. Okay, yeah. So I believe, like you said, the sill track does stop, like you said, maybe a 32nd or 16th off of that edge. So that would mean I would have to, if I show these lines, I have to trim it there.
Yeah.
Right? Not anywhere else. And see, and some details show these lines going all the way through, which is wrong. But you're exactly right. See, so now you know where these lines start and stop.
Yeah.
And what they mean. And yes, and that's a standard error. We should remove those from our jam details, because technically that's wrong. That was our old design. I say nobody's ever caught that. But yes, you're right. See, so now you have power, and then, oh, you see here? Okay, just, it looks like an error, but it's not. So you see how the chicken head overlaps the end dam. So it looks like, oh shoot, that end dam's too big. You have to remember
the chicken head
is higher, and that end dam is down here.
Right.
So it's technically the end dam is below it. So it's actually correct. So just kind of a little caveat there. It looked like it was wrong, but it's not. Okay, but that's what these lines represent. And then the powerful one here is you see the sill track, the front. It does not go all the way to the front of the system. So we have to remember that because that's where the sealant is. So again, if we look back at this detail, the sealant is way back here.
Right.
So it's really
an inch back,
an inch and something behind. So if I'm gonna, I wish there was some doodle line on CAD, but there's not. Let's just say, so let me just exaggerate it. So let's just say we're imagining, how does the sealant go underneath these units? Really, let's see. Okay, yeah, the sealant goes here. Okay, Okay, so that's kind of on top of everything, but really it's underneath, right? So imagine that sealant I just drew is this sealant down here, under the sill track. Okay, so it's underneath all of this, but you see how far away it is from here?
Yeah.
So that's where the field, why the field needs this leg. Because now they could put sealant up and across to marry those two together.
Okay.
So that's why that leg on the end dam is super critical on the captured.
So
in an Inviso, huh?
Because it's notched, isn't it? On that end dam, it's like it's
It's not
notched.
It's like this.
Yeah.
Yeah, so that they could
notch it.
So yeah, that's a standard fab.
Okay.
Yeah, so that way they can track the sealant all the way underneath the sill track, and then they can marry it with that perimeter sealant, and it actually can touch it. Yeah, so that's where, again, you have to think three-dimensionally, but that's why it's good to see where the edge of that end dam or sill track is, because again, the misconception is, oh, it's all at the front, but no. So that's why it's critical to see, like, again, this is where, coming to understand how the details relate to each other. That's why sometimes when you see, sometimes we see jams with the sealant way back here, and you can say, oh, that looks fine, but no, now it doesn't marry with my sill track. See, so that's why this jam, you can just look at the jam and be like, okay, yeah, that looks fine, whatever. But you have to see, how does it relate to the parts below it and above it and at the end. And so right now we're just focusing on the sills. See, so we're going to do the same exercise at horizontals and heads and stack joints. So you can see how they all relate to each other and how one little thing like that, moving a sealant joint, could affect something else. And that's why we have to learn to look three-dimensionally. Beyond just the detail itself, because the detail is one thing for standards, but this is understanding the constructability between the other components of the sills, the stacks, the horizontals, etc. Okay, so far so good. Okay, so okay, so then seeing these lines, so we used to show these in our details to help clarify things, but again, there were just too many clutter, and sometimes, again, they were drawn wrong, again, because drafters didn't always know what they meant, and they didn't do this exercise to, take the sill track below and trace it through. So sometimes they would move the lines, offset the lines, delete them by accident. Some would be there, some wouldn't, like you saw here. Sometimes they'll end it in the wrong spot. So too many errors. And again, the drafters just didn't educate themselves enough to know what they meant, to check it or to do it proper. So it was better to take them out. Because as you can see with all the lines, it is a bit cluttery. And then like these inside here would be solid because you could see through them, but then over here it would be hidden. It's just a bunch of drafting work that didn't really add any extra value. But if you have a tricky detail, and that's why at the doors we keep it, because it helps clarify where things should go, we can always draw them in on a construction layer, or something like that, as long as you put them in the right place. And you can use them as your own reference for some kind of layout or like a tricky detail that you might be working out or you're trying to understand. Because they are helpful, but that's only helpful if they're drawn right. So hopefully, finding a point like I did here that you can use as a reference in relation to the vertical member is always good. And then just making sure you use your AutoCAD properly, insert it using that corner and rotate it 90 degrees and you should be good. Because this also comes into play at the corners, just to see how it relates to the corner body. And if you have some weird stuff going on, it's just good to track it through to make sure nothing is missing, there's no holes, and that these parts interact correctly with the sill track below. Okay, so I had a little exercise planned here just to hopefully visualize things. Okay, so with what we went over, I just wanted to kind of see if we could put together a little model of the sill in relation to the vertical. So that's all we're going to do as practice. So I have it started, and let me change my view. Hopefully AutoCAD doesn't crash. Okay, you know what? I should probably split my screen. Oh, come on out of here. There we go. Okay, so this will be hidden. This will be 2D wireframe. Okay, there we go. So we can see the 2D detail and the 3D over here. And let me just move it so we have a little more space. Okay, so just to kind of help practice the visualization of where these things go. So we have a sill. I just have the captured sill and the sill track. And all I did was copy and paste them from the detail. So they're in the correct location in relation to each other. But right now, I just have it pasted at the bottom of the vertical member. So it's not in the right place. So from the details, can you tell me, how can I fix this? What do I need to do to get the sill member in relation to the vertical correctly in the up and down location?
Okay, so are you saying that horizontal, like that main like sill is in the right spot right now, or it's not?
It's not right now. Up and down, it's in the wrong spot.
Okay.
So how can I tell from the detail, where do I put it?
Well, so that, one second. Sorry.
It's okay.
So that, let's see here. So in relation, so the vertical, okay, hold on, what did I say that was that main body? That sill main body needs to go up, and the pocket of the glass should be in line with the vertical. Like,
Yeah, so it is. It's in the right location in and out. It's just up and down. It's in the wrong spot.
Right. So it would need to move up.
By how much? Or how do I know from the detail? How can I tell? How much do I need to move it up?
Let's see here. A ½ inch.
From where?
From here.
Okay, so that's the sill track in relation to the sill itself, right?
Right.
So you got to remember where.
Right spot?
Well, so right now, let me draw a construction line here.
Sorry,
maybe my question's not clear. Hold on a second. Let me draw a line. And I guess construction layer. Okay, so right now, according to my model, I have the bottom of vertical right up here, which is wrong, right?
Yeah.
So what do I need to move to get it in the right location? So right now I have bottom of vertical is equal to top of sill. So that's not correct in my model.
Oh, it needs to go down.
Yeah.
This notch line, because that's what is representing the bottom of vertical.
Correct. Exactly. Yes. Very good. Yeah. So here's that 7/16 bottom of vertical little tab, right? Okay. Yeah. So that would be, so I would just have to pull, see again, we don't have this dimensioned any other way. So I would just have to pull a dimension just to see how far I gotta move it. So 2 1/16. Okay, so I'm just gonna grab this whole thing and I'm just gonna move it up 2.0625. Okay.
Okay, there we go.
Okay, so now you'll see. Okay, so there we go. So now you can see the bottom of the vertical, which is the cyan.
That notch line, okay.
Is equal to the bottom of that, which is exactly what we want, which matches our detail, right?
Right.
Exactly, perfect. Okay, so now I'm going to move just the sill track through, because it's actually going to run through.
All the way through.
Okay, yeah, so I'm just going to just move it so we can visually still see it. Okay, but now.
But that, wouldn't the face cover need to be ran through as well, or not all the way through, but it stops in the middle because it like.
Okay, so hold on, we're not going to get to the silk price covers yet.
Okay.
Yeah, but no, we'll get there. Yes, so yes, but see, like, this is where the 3D visualization is going to help you see what's wrong with my model, right? Okay, so now I just moved the sill track through because in reality it will run through.
Right.
Right, but now you can see it's hitting.
Oh, we need to notch it.
Right, so that's why we have to notch the verticals, right? Because otherwise you'll have this and you can't have that.
Doesn't work.
Right, it absolutely does not work. Okay, so to do the notching in CAD, I mean, just to show you a little bit of, I just thought it might be helpful for you to see. All I did was I traced that notch with a center line, a construction line. And I kept my sill track on as my guide. And then all I do in AutoCAD is I do a Control-C, and again, I just keep using the back point because that's my reference point. And I just copy that line. And then I go back to my model, and we use a command called VPE, which means viewport end, which means it'll turn it 90 degrees so that you're looking directly at it like this. So it's a nice little command. And then I just do Control-V and I paste it and use the backup corner of that. Okay, so right now it's just a line. You can see it's pasted it way at the end. And so what I do then is I extrude this little thing, some big number. And then just because I know I'm going to have to do it twice, because I have to notch the male and I have to do the same notch for the female. I don't want to do all those steps again. So I copy this thing before I subtract it. So I copy it over, let's say 12. Okay, and then I'm just going to now do the basic notching in AutoCAD, which is subtracting. So I hit SU for subtract. I'm going to subtract from the male, and then I'm going to select this guy. And now it just notched my male. Okay, but the female is still not notched because I didn't select it. Okay, so now I'll move this second notch back 12. So now I know it's exactly the same notch and exactly the same location, and do the same thing, subtract, but now I'm going to subtract from the female. And that way I didn't have to draw that notch twice. So now that female is notched as well. So let me move this out of the way for a second. So there you can see now I have the female notched. Okay, so yeah, so that's the whole purpose of the notches there. Okay, so now you can see why we need it. Okay, so they have to notch it to go up and around these sill track, because the sill track is going to keep running through like this. Okay, any questions there so far? Okay, perfect. Okay, now, yes, we can get to the face covers and all these other parts to see how they relate. Okay, so the body of the sill attaches to the female or the male. And so we call that the daylight. So it just gets cut straight and gets attached. So this is body part is correct. But yeah, the funky stuff happens at the front. Okay, so let's look back at our details real quick. So let's see if the details tell us anything. Okay, so first of all, this detail does not tell me anything else. So again, to me, it's still missing a little bit of information. Okay, so we don't show the line of what happens at a captured face because that line is gone. So again, the line of the captured face is actually here. Okay, so the line of the captured face is right here. Okay, but the line does not stop at the top of the sill.
It goes through.
And it doesn't stop at the bottom of vert. But right now, that's where I have it. Okay, so you can see right there. That's currently now, this is where my model is, which is not correct.
Right.
Okay, so right now I have everything equal to the bottom of vert, but that's not true. So where should the face cover on the vertical actually end?
On the vertical?
Yeah, on the vertical.
Should stop at the daylight of that.
Which would be where?
Right here.
Well, so the vertical cover, if it stops up there, the sill member, this horizontal then would have to run through. Our standards, our verticals run through. Captured verticals run through.
Okay, hold on. Then the vertical should stop.
Yeah, the face cover.
Can you zoom out of the 3D one so I can just look at it?
Mm-hmm. Yeah, so right now it's up here. Where do you think it should be so that it looks better?
It should move down.
Mm-hmm.
7/16.
Exactly. Perfect. Yep. So we don't show that though. See? So that's a defect in our drawings. Sometimes we show this line down here. But yeah, it looks like a floating.
Yeah, that's that notching that comes down.
Right. And so then, yes, so now though, there's some weird spot where now something stops down here, but the rest of it stops up here. So this is where fab stuff comes into play. Like what goes through, what stops where? Exactly. Yeah. So the face cover though itself is its own separate piece. So if I look now at my vertical, right? So the magenta is this guy. So that in itself, that's what's visible. That's the face cover. That's going to be down 7/16. So I'm going to grab that and move it down 7/16. Okay, so now it's a nice clean line. Okay, and you see that little offset? Yeah. That's on purpose. That's that same little offset you see here. That stupid little O2. Yeah. Right? So, but it makes itself evident when you do this. But that's why our profile lines, we're just going to ignore that little offset because this is what they would see in Revit. Also, if we kept our profile lines to the face of the sill. So that's why we're just going to make the profile lines go to the face of system, right? In our CAD drawings and profile lines, right? Yeah. Okay, perfect. So now we have that, which is good. Okay. But then, yes, so if we go into our vertical a little bit more, we have this piece, and this piece still. Right. Right. So we know where the body stops. We know where the face cover stops. So now see, this is like what Fab would have to figure out. Fab team, where do these guys stop? And do they need any notches? Right. So that's kind of like where you got to think like a Fab person because see, detail wise, we're done. Yeah. But for them, they have to know, well, where do these stop? So that's where the logic comes in. And that's where we have to know, at least it's nice to know where they start and stop stuff. So if we stopped this cover at 7/16, it just makes logical sense that this piece also stops at 7/16 because that's what it's attaching to. Okay, but do they do that for sure? I'm not 100% sure that they do that, but that's what I would do. That's what makes sense. But I think they do. So I think they keep the relationship of this cover to the face cover the same because that just makes them easy. They have the same cut size. So I'm going to move this in our model. I'm going to move mine down also another 7/16. So now I'm going to take the blue guy and I'm going to move it down. Okay. So then we have this guy and this guy. Okay. So these two pieces are somewhat independent of these two pieces. So they don't have to have the same cutting plane. And they don't have to have the same cutting plane as the body because technically they're on their own, sort of. So this is where, again, Fab logic has to come in of where do they start and stop these for that makes it best for them. So this is where the Fab team has a little bit of play because it won't kill us if this is at 7/16 or if it's flush, or it doesn't matter really because it doesn't hit anything. There's nothing in that cavity. So you can see the sill runner runs through, but there's nothing here. So they have that whole space to just kind of play with, sort of. I say play, but so they could put it wherever makes sense to them. And so I think they stop it at the 7/16 line up here. So I think the only thing that runs down here is this pressure bar plate and the face cover. And then in our details, we usually draw the line that goes up here to show that. And again, that's what's missing from this detail. But if I dimension this, that's 3/4. And so if I go to the vertical detail and I just draw a line from 3/4, those are the only two objects that are in that 3/4 spot. So that just leads me to believe that they will stop this part and this part at the bottom of body. Does that make sense? Did I lose you?
No, you're good.
Okay. Okay, so in our model then, again, if I just move these guys out of the way for a second. Okay, so this is where we are. Okay, so now let me do BPE. Okay, so now if we look at my model, now it looks closer to the sill detail. Right, does that make sense?
Yeah, I see it.
Okay, yeah, see, so that's what we're trying to depict, see, in 2D, what's happening way beyond in that plane at the mullion level, but then also what's happening here, way over here at the splice sleeve level. So that's why, again, our 2D details are very hard to understand at some point. So hopefully this exercise is helping visualize things so you can kind of see what relates to what. So I'm going to move this back 12 so you can see how it goes together and see how that matches that.
Mm-hmm.
Okay, and all I'm missing is the anchor and the index clip, right?
Right.
Okay. Okay, so all of that logic still applies if it were Inviso. Okay, so I don't want to ignore the Inviso, but the only difference is I don't have a captured face to end with. So the vertical cover, if I have a vertical captured that butts to an Inviso, again, it kind of may look weird. Usually architects don't do that normally because it doesn't look good normally. But that's where I don't know for sure what our standard logic is of that. So if we had a captured cover, I think we would stop it here at this plane.
Mm-hmm.
But I'm not 100% sure. I mean, we could stop it here because there's nothing to align with on this side. So I don't know what our standard logic is for that. But it doesn't happen really because it's not really a nice looking design. But doesn't mean it won't happen. But that's where you have to think about it beyond. And even though our details don't always show it, that's why it's always good to not just look at the sill by itself. It's good to look at, okay, what's my verticals look like? So then you can see, do I have a captured face? Do I have an extended cover? Or do I have an Inviso vertical? So that way you have to see the details together so you can understand how they relate to each other. So that's why usually when I see a profile set that has some kind of fins or extended covers, it's good to go to the elevations to see, okay, if that's where the cover goes, what happens at the ends? What happens at the jambs? What happens at the vert? Does it hit a corner? Does it hit a soffit? Does it, right? Because now you have to see, what does that piece start and stop? So you kind of have to think of like a fab person. How would they start and stop this thing? Where would it go? And especially if we don't show the lines in our details. So that's where we find mistakes from Jumpstart. They may have missed it. They didn't show the lines. So we don't know where it starts and stops. So that's kind of stuff just thinking about when you're reading or looking at some sets of drawings. Anything that's sticking out, we should see how does it end and what happens at each vertical condition that it butts up to. Okay, so that is this guy. Let me see, anything else on this? I think, I mean, that would be the basic intersection of a vertical to a sill. Oh, one more thing, sorry. No, there is one more thing. So on our verticals, there's a little cue for the cap. There's a little cue they give us for this captured cover. So that's what these lines represent.
Right.
So these two lines represent the lines of the face of this guy and the back of pocket here.
Right.
But you know, there's an inaccuracy because see, they're not showing that 0.2 offset. Really, that should be 0.02. It should be in like that.
Okay.
See, so again, another error, right? But that's, to be accurate, that is how those lines should be. Okay, but you see this little gap here, this 1/16.
Yeah.
Okay, so that is on purpose, just on this side, this left side.
On the female, right?
Of the female side, correct. So the reason for that, so let me move this. The reason for that is so that they have space when they install it. So if you remember if you think about the way this gets installed, okay, this sill member with the captured face is already attached to this female unit.
Right.
Okay, but this captured face, this guy, all of this is part of the male unit.
That comes in.
it comes in separate. So let me just grab, all right, let me move the sill track out of the way. Okay, so if we were to do this properly, okay. Okay, so all of this is one unit.
Right.
Then the field has to come in and put this unit in. But they don't do what I just did and move it nice horizontally.
No.
It actually is coming from the front down.
Right.
So again, remember, they use their little pickers from the top. They're lifting, you know, like a 15-foot tall unit up, and then they're sliding it down, and then they shift it over.
Yeah.
So they're not just doing left to right, like you would kind of hope they would. If they can, they will. But the way our system is designed is to go from up down.
Mm-hmm.
That's why you have to go up and over the chicken head. They have to go up and over the anchor bolt at the top, right? So that literally you have to imagine this unit coming down. So they don't want this metal to be scratching this metal. So that little 1/16 gaps just gives them a little bit of clearance when they're installing these, so they don't hit each other when they install it. And that's why it's there. So, and it's only on one side, so that way we don't have a big gap on both sides. And then I don't think they do, I don't know if they do. After it's installed, the field may, you know, tap it over a little bit to close that gap a little bit, you know, to make it look cleaner. If the shop might have accidentally cut this 1/16 a little bit big, you know, if it's a big gap, they're going to try to make it look clean. But really it's just for installation clearance of units to units.
Okay.
Okay, so yeah, so that's on purpose, and that's only on captured to captured. So then you can see at Inviso, that's what these lines mean.
Yeah.
So at Inviso, the covers run through, the horizontal cover would run through and have a little 1/16 gap. So that's what these lines are representing. So that's why these are important to show in the details too.
Okay.
So any questions on the sill or sill track, sill runner, the notches?
No.
I hope I covered everything.
That's good.
Are there anything in the details that you have questions on that maybe you just didn't understand what they were, or maybe I covered it?
You've already covered it. Like I have some notes are written down.
Okay.
Things that I didn't know.
Okay, cool. Yeah. All right, awesome. So this stuff here, these, if you want to do a little further study, like I said, there's actual installation manual sheets, you know, for these. So you can actually open those up and just read the steps, you know, because we don't show everything. Like I said, we try to show as much as we can, but the steps actually spell out the order and, you know, how they do it, the bedding things and sealant and all that kind of stuff, if you want to, just to kind of reiterate what I've said here. And then I'm going to save this recording for you. And then I have this sheet I'm going to save. So if you want to reference it, it's just going to be in our training folder. So I have the Team Esley and then training. So right now I just put W75 Sills right here. So I might make a separate folder. Maybe I could put it in this details 101 maybe.
That's fine.
Yeah, and then I'll just put it by sill, and then so the next one we do, I'll go over horizontals, which should actually be shorter, I think.
Okay.
Okay. So let me stop recording.